The question we are solving now belongs to test series 10. It is of control system subject. In specific, it belongs to Nyquist analysis. As per the question, the open loop transfer function of a unity negative feedback of the unity feedback control system is given as 10 by s multiplied by 1 plus 2s multiplied by 1 plus 3s. Please note that this is a common data question. As per the question, we need to find the gain margin of the control system in dB. So upon substituting s is equal to j omega, we see that g of j omega multiplied by h of j omega is equal to 10 by j omega multiplied by 1 plus 2j omega multiplied by 1 plus 3j omega, that is equal to minus 10j multiplied by 1 minus 2j omega multiplied by 1 minus 3j omega divided by omega multiplied by 1 plus 4 omega square multiplied by 1 plus 9 omega square. This is upon multiplying both numerator and denominator with 1 minus 2j omega divided by 1 minus 3j omega. And we can get the phase crossover frequency of the control system by equating the imaginary part of g of j omega multiplied by h of j omega to 0. And upon doing the same, we see that 1 minus 6 omega square is equal to 0. That implies the phase crossover frequency is 1 by root 6 radians per second. So from this, we can calculate the gain margin as Gm is equal to 20 log 10 apps of 1 by g of j omega p multiplied by h of j omega p. So upon substituting s is equal to j omega p is equal to j by root 6, we see that g of j omega p multiplied by h of j omega p is equal to 10 divided by j by root 6 multiplied by 1 plus 2j divided by root 6 multiplied by 1 plus 3j divided by root 6. So this can further be simplified as 60 root 6 divided by j multiplied by root 6 plus 2j multiplied by root 6 plus 3j. From this, apps of g of j omega p multiplied by h of j omega p is equal to, that is a magnitude of the g of j omega multiplied by h of j omega at phase crossover frequency, 60 root 6 divided by root of 6 plus 4 multiplied by root of 6 plus 9. This can further be simplified as 60 root 6 divided by root 10 multiplied by root 15. And upon simplifying the same, we see that this can further be simplified as 2, 5, 1, 5 equal to 60 by 5, that is equal to 12. From this, we can write that the gain margin of the control system is 20 log 10 1 by 12 dB or minus 20 log 10 12 dB. So we got the gain margin of the control system as minus 20 log 12 to the base 10. Hence the correct option which represents the gain margin of the given control system is